Right. So, okay, hello. I'm here to talk about the FN project, which is a serverless platform that I work on. I work for Oracle. I work in the United Kingdom. I'm happy you all came to the basement to see me. So, all right, should we start? All right, fine, whatever. So, FN project, like I said, is developed by me and my team. There's about 25 people on my team. I'm in this place, in Bristol, not here. And then some people based in Oakland, in California. And FN is this open source serverless compute platform, which, I don't know, have you been to other serverless talks at DevOps PL, right? Everybody has. So they all seem to be talking about the same thing, right? At the start, there's like an explanation of what is serverless and what is a function as a service and what does it get you. And I have a slightly different take on it because of it being an open source platform. We are encouraging people not only to think about the serverless platform, but also about not being tied to any particular vendor, but being able to run your serverless platform wherever you want. And if you can find someone who will run it for you, so much the better. But FN is Apache 2 licensed. We're encouraging people to try it out and run it for themselves if they have hardware. And we're working on building a managed service out of it as well. And, you know, serverless is this silly word, right, which obviously implies there's no servers, but there are. And in that sense, you might think something like a database as a service is a serverless product because you don't see the servers, or even a hosted web server because you don't care about managing those servers. But serverless compute platform is a little bit different. It's about running bits of your code on demand in response to events that are coming in from users, like HTTP request comes in, we run some of your code, a response goes out. You are responsible for writing the functional bit of your code, and we're responsible for the whole platform and the as a service, the scaling, the reliability, the patching and upgrading, the dealing with hardware failures. All that is out of scope for you. So we typically refer to this kind of thing as functions as a service, don't we? So you may have seen a slide like this in some other people's talks. But this is my interpretation of it, right? When you're running a modern cloud web service, there's this kind of stack of stuff, isn't there, that starts with the hardware, or maybe it's upside down. There's hardware, an operating system running on the hardware, some hypervisor for virtual machinery, another operating system running in the hypervisor. There's containers orchestration, and then there's your application code. And of course, like, you're free to do all this stuff yourself. If you want to buy computers, plug them into the wall, plug them into the internet, keep them all running, deal with hardware failures and installing patches and all that, that's fine. You can do that. And for some companies, it makes sense to do that. Some companies operate at a scale where doing this is cost efficient for them, right? These days, most of the cloud providers let you rent a bare metal instance where you get like a whole actual physical machine for yourself. And that frees you from having to worry about the hardware, but the rest of the stuff is all your problem. Platform as a service, I'm thinking like when you're renting a VM, then there's another couple of things that you don't really have to care about. The operating system that's underlying the hypervisor and the hypervisor itself, right? Who cares about that as long as you've got a machine that you can SSH to and install some stuff on it, but you're still responsible for managing that machine. And that kind of stuff takes time away from what you presumably want to be working on, which is like building a product or like messing around, playing games, whatever. These new Kubernetes as a service kind of platforms, they abstract another layer where you don't even really care about what operating system it's running on. You deal with container images. They get scheduled to some host somewhere, and you provide what goes in the container image, and you just assume it will run wherever it's put. Okay, and serverless is like the next step on this rung, where you don't even care about the container orchestration. All you need to worry about is your application code. And this is why it's nice, right? Because, well, I'm right in the shadow. Like, the bit that's your problems. And like for some companies, I'm not going to say serverless is like magic for everything. For some companies, worrying about these kinds of things in the red is like it's going to get them a competitive advantage. There are savings to be had when you've got like a scale. You are very you can get a company that's big enough to be worth hiring people to look after patching kernels and that kind of thing. But for most companies, this kind of making things someone else's problems so that all you have to worry about is your application code is appealing. So that's kind of the benefit that that's of serverless. And the model is different as well. You know, when it comes to deploying code, you deploy functions individually. They are scaled independently. So one function, if it's very busy, you can have 100 of those. One function, if it's not being used, you should have 0 of those. And you pay for what's actually being used, right? So you don't need to you don't need to do the capacity planning, but you also your amount of money you spend is directly in proportion to how much your service is actually being used. So it's very, very cheap to try things out on a kind of 1 or 2 hit basis. And if your service suddenly, you know, if it's advertised on TV and you get a sudden rush of hits, you pay for the capacity that's used, and then when that dies away, it should scale back down to 0. And that's a kind of core feature of serverless compute platforms, is scaling down to 0 and the cost being proportional to the scale that you're using. So there's this kind of slightly different architecture as well with serverless platforms where you have to build everything as a function. This is different, right? The monolith where, you know, there were lots of functionality in one thing, and then there was a decomposition. There was a kind of trend for microservices where independent scaling and so on and resilience became important, and there was a thing about, like, you have lots of microservices, you have lots of interfaces between microservices, and you have to worry about your APIs, which you didn't really have to do so much in kind of big one ball of code kind of deployments. And function seems like maybe it's going to suffer from the problem of that. But again, because we always say functions should be small, they should be single purpose, but then surely if you have any kind of complexity in your application, you're going to have a shitload of functions. And so I'll talk about how FN is different and how we have a proposed kind of solution to this problem. I'll do a couple of demos, and then at the end, when I know you all want to leave because there's like the long queues for lunch, I'm going to try and tempt you to stay by having a demo that's like a game that we can all play together. So what's FN different to other serverless platforms? So other serverless platforms, I mean like AWS Lambda, Azure Functions, Google Cloud Functions. There's IBM OpenWhisk. There's one called FaaS, Project Riff by Pivotal. There's tons, right? What makes FN different is, firstly, the strong emphasis on being open source, right? So you can see how it works. It's not just about being able to run it yourself, but you can see how it works. For me, I was always a Java programmer for a long time. And when Java was open sourced, that really appealed to me because suddenly I could see, like, how does it work internally? I can click through and I can find out, like, what's going on under the hood. I can talk to you a little bit about how the internals work as well if you want. You can also deploy any cloud. You can deploy it. I'm running it on my laptop and on a server in the in the Oracle cloud. Excuse me. This is a picture here of someone who's deployed FN to a bunch of 4, 5 Raspberry Pis, and they're using it for home automation. Right. So it's this event-driven architecture, and what's happening here is the event is some sensor has detected that the car is on the driveway, and the function is opening the garage door. And this guy is running FN at home. It's independent. It's Apache 2 licensed. So although most of the people working on FN, or a lot of the people working on FN work for Oracle, Oracle has no say over who uses it. And the Apache 2 license encourages or allows other people to use the service in commercial setting. And it's an attribution. Like, you can't take it and claim that you wrote it, but you can use it for pretty much any purpose. So Apache 2 is very open license. The strong enterprise focus there is to say that we, well, have you seen there's another talk about serverless that's, it wasn't here, but someone's giving a talk about writing a serverless platform in 100 lines of code, right? And it's pretty straightforward in some sense to have something which takes little blobs of code and runs them on demand. 100 lines of code, you can do it. But to make it scale, to make it a multi-tenant service, to make it resilient in the case of partial failure of the underlying hardware, to sort out monitoring, metrics, and logging, and that kind of thing, that's like all the details where the devils always lie, right? And so that's what we mean by strong enterprise focus. We want people to be able to run production workloads on FN and to bet their company's reputation on the services that FN is running for them. So we focus on those kinds of things. And then like functionally about FN, the biggest difference that you'll notice if you try and use it, which I encourage you to, I'll show you how in a minute, containers are the primitives, right? So most function platforms would say, here's a Java library, import this, you can use Java. Or here's a Node, or here's Python. And there's a few different languages that they support. And if you want to use something else, you have to do some kind of, basically you can't, or it's unsupported, or you have to do some kind of hacking to work out how to bootstrap your own thing. FN takes the opposite approach, that anything can be a function. I'll show you some functions that I've just written with shell scripts in a bit. Anything which is a Linux process that can be containerized can be used as a function, right? So it's very, very flexible. And if you think of like the hello world of serverless these days is usually like someone uploads an image. I saw this in a talk the other day. Someone uploads an image and the function resizes it and creates a smaller version of the image and puts it somewhere. So why would you want to write code to do that? There's like image magic has been around for decades and it does exactly that. So why not be able to use tools that already exist, right? And just plug them into your functions platform. So the question though is like, so how many people are using Docker or some other container thing regularly? Maybe like a quarter or something, third of you. Okay, and how many people have like a good, solid idea, I guess, of what containers are, even if you're not using them? Okay, maybe like, well, it's a pretty, because I might pick on you and ask a question, right? So you don't want to put your hand up to that. So it's not like a VM, okay? A container is a Linux process. It runs on the host, just like all the other processes running on the host. You log into a host, you run a container, and the containerized process is running on the same kernel as your login shell, right? It's not like a virtual machine. But what's different is the containerized process runs in a sandbox of some kind, right? So it has a restricted view of the host. So it can't, for example, see or interact with other processes that are running because they're hidden by a kernel namespacing mechanism. This talk is excellent. Jesse Frizzell, where's my shadow gone? There you go. Containers from user space. These slides are online. You'll get them from the conference website or from my Twitter. So this is like the best 40 minutes you'll spend if you want to understand about containers, right? I won't go into more details. Except to say, like, a functainer, I don't think that word's going to ever catch on, but a function container is a particular type of container, right? It's got to be this short-lived, stateless, because you can run like Oracle database in containers if you want, if you're that way inclined. You can run long-running application servers. You can run Apache and it will stay up for months. You can run lots of different kinds of things in containers. But for a function container, it's also got to fit this functions model of being preferably small, like single purpose, and event-driven and stateless, right? So you don't get to keep any state in your function. You have to store it somewhere else in a database. I'll show you an example of how I did this later on. So what do you put in your container? A process, right? A Linux process, like I said. And what can every process do? It can read standard in and write standard out and standard error. These are like POSIX primitives that everything should be able to do. If you know a programming language that doesn't support those 3 input and output streams, like come and tell me about it, and I'll tell you how to use it on FN, maybe, if it's possible. I think every programming language can do that. Some languages we've written some libraries for some languages as well to be able to use these streams more easily, because what arrives on the input is this CNCF standard format as a cloud event, right? So you've written a process. It's going to receive something that looks like this on standard in. And if you're a Java programmer, you might think, like, this is going to be a pain in the ass to deal with because, like, parsing JSON in a statically typed language like Java is always a bit difficult. So what we've written in these FDKs is just a few like helper methods really to deal with the I/O. I'll show you what it looks like when I use the FDK in a while. So input, output, standard error, FDKs. Got it. So let's have a look. I've got a shell here, right? And the whole of FN is dealt with using this command line tool called FN, right? I can create a new function, FN init, and just to show that it's like able to use like some other slightly esoteric languages, I'm showing you the Kotlin sort of template function. So what's created when you initialize a new function is a little bit of Kotlin. Does anyone here program Kotlin on the regular? Okay. So I'm I'm overwhelmed by Kotlin experts then who are going to laugh at my poor code. I'm sorry. Like I said, I'm a Java programmer. So here's a function, right? It defines an input type, which is going to be mapped in from some JSON. It defines a response type, and then a function, right? And the Java support looks exactly the same. There's no interfaces to implement. There's no dependencies that you need to add to your code. We will just be able to run this, right? So if I can echo. So I need something that's going to match this input type, right? So, oh no, keyboard mapping. Name, devoxpl. Okay, so FN run, it like it says, it builds a container for you. So it knows how to, because the project was initialized using a template, it knows how to build that into a Docker file, a Docker image for you, and that's what happens. If I stick a -- verbose, you'll see like the full details of what's happening. It's just copying the source in, it's running Kotlin C, it's creating a jar file out of it, and then at the end it's running it, and you get exactly the output that you'd probably expect if you were following along, right? So that's fine. What you'll see, though, is that there's no, like, apart from this like little metadata file that just lives next to your function and contains a few things like the name of it, the version of it, how to build it, and which images, which base images to use at build time. There's nothing else there, right? So if you're used to using IntelliJ or NetBeans or whatever VS Code, whatever IDE, whatever build tools you usually use, it's all just files on disk, right? There's no like typing code into a text area on a web page. There's no kind of like having to use a particular IDE to get a particular plugin to be able to do this kind of thing. So FN run, I just showed you. This is the local development, right? So this has not been pushed to a server. It's built an image. It's run the function. It's passed the input to it. The function's run, and it's got the output back out, right? But I haven't deployed it anywhere. I am running by just typing FN start. You can run a local copy of the FN server, which is just like a everything in one binary kind of version of the distributed control plane and everything that we run in production. So FN list apps. Oh, hang on a second, sorry. FN API URL localhost. I'm just running it on a different port from normal because the Wi-Fi here doesn't let you connect out to port 8080. Who knew? Okay, so I've got my Kotlin app here, right? And I can FN deploy the current function, which is like the one in the current working directory. I can deploy that to the app that's called Kotlap. And I'm going to put -- local. And that means like don't push, because I know the server's running locally, I don't need to push the image to any registry or anything like that. The thing's already going to be available. So I've deployed to this app on this path which means I can curl. Have I got that in? No. Okay. Curl minus D, the same JSON as before. You can see where this is going, right? Oops. Devox Polando HTTP localhost root is kotlap. And the function is called function demo, apparently. So this is exactly the same kind of thing, right? But now it's deployed to a service, and that service can be like anywhere on the internet, so you don't need to be running it yourself now in order to use it. I should have timed that, never mind. What you'll notice is the first time you run it, it usually takes around maybe a quarter of a second to spin up. And then the second time and subsequent times you run it, it's more like this, where it's like 50 milliseconds or less. And the behavior here is, this is referred to like the cold start problem. And that's because on the first request, we need to create the container, start it up. With the Kotlin app, we need to start the JVM. And this is not using Graal, sorry. So it's going to take a little while to start up. And in order to speed up the behavior of busy functions, we keep this function so-called hot. So next request that comes in for this same path, we'll be able to reuse. So we don't kill the JVM as soon as it's finished. We don't kill the container. We'll be able to reuse the same thing. So it's sat here, right? And it sits in this state here, which is paused, as in paused in the sense of Docker pause. So that means the kernel is giving 0 CPU cycles, but it's still in memory. If I run it again, it's probably timed out now. No? Yeah, so that was the first one. So it started up a new one. And now, yeah, this one's been up for 6 seconds now, and it's paused. So reuse it. Oh, sorry, reuse it. So this is a way that we get better performance for busy functions, right? They're called hot functions when they're in this state, so we avoid, because we are avoiding the cold start. So like Kotlin's just an example. You can write these kinds of things in any language that can be containerized, like I said. Okay. So I've jumped through like what is serverless and what is FN a little quickly because I wanted to get to this point, which I think is an interesting point. Like when you use a FaaS platform, you're encouraged to decompose these functions, small, testable, independent, like that kind of thing, like methods on an object. And then suddenly, if you've got an application that's representing any kind of complexity, you're going to end up with a lot of functions. You know, functions calling functions. So if you're paying for something that's, if you're paying for the time that something's running, if you have like function A, and function A has to call function B because, you know, that's how, you know, workflows exist in complex apps, right? Then suddenly, like, A, you're paying for it whilst it's just waiting for B to run. And also the idea of like just calling one from another or taking one result and passing it on to the next thing is like it's very difficult to manage the complexity because you're sort of hard coding the workflow into the functions. And what we'd like to do is keep functions independent of each other, but provide a way to compose them and build up like complicated behaviors out of simple functions. Right, that's how all my programs work. So we have a part of FN which is called FN Flow. Flow lets you build these scalable, distributed applications out of independent functions. And also, the workflows themselves are defined as functions. So there's no kind of, like some of the other platforms that offer these kind of workflow definitions, you have to write a big JSON document or a big YAML thing that says, do this, then do this, then do this. And if that fails, you can do this. Flow is a lot more flexible. Firstly, it's in code, so it's testable. But it can also be self-modifying. You can put branching, you can put retrying, you can put exponential backoff on something. Like it's all just there. Like I'll talk about it in how the code looks in a minute. But still, they're normal functions, right? So they scale up and scale down in accordance to like how much demand there is for them. So here's an example, right? We're going to look for pictures of stolen cars. we already have like a bunch of useful functions written in other languages. We've got a function called scraper that calls the Flickr API and just gets a list of URLs of pictures of cars. We've got a detect plates function that's written using the Go open license plate recognition framework that's really, really good. We don't want to have to re-implement that. We've got a draw function that uses image magic to draw little squares on pictures, and we've got Twitter and Slack like notification posting functions. And what we'd like to do is something like this. Okay, so we want to go here, get some data from Flickr using the scraper function, and then for all the things in that response, there's going to be lots of images in the response. Call the plate detection function, and those can all happen in parallel. There's no reason for them to be like chained up to each other. If the plate detection function succeeds, we'll draw a box around the plate and we'll post the image to these two things, and they can again happen in parallel. So I told you already, these functions already exist. And what flow is a way of flow is a function that basically is like the red arrows on this diagram. So what does the API look like for flow? It's a kind of futures-based API, right? So you invoke, can you see my mouse pointer? You invoke the scraper, and then you can compose. So you do one thing, and then you compose multiple other things on it, and then for each of those, you can optionally choose to compose another thing here, and then when that's finished, you want to do all of this and this. And then when it's complete, you want to post some message somewhere that says, okay, I'm finished now, or if any error has happened. So does that API look familiar to anyone? Any Java programmers? Okay, no, it's a pretty not well-known API. In Java 8, there was this completable future API that was added. Completable future is a future in the sense that it represents an asynchronous action that will eventually, it's like a box, and it will eventually contain the result. And the completable future is like a chainable thing. So when the result is available, then you can do another thing. So you can set up these chains and sequences and bifurcations and joining and splitting and error handling. But completable future is for orchestrating asynchronous methods within a single JVM. And what the flow future is an analogous thing, but instead of using a thread pool, it uses the functions as a service platform for running these things asynchronously across a distributed compute platform. So this is what the code looks like. It's typical Java, but it's only 30 lines long, and half of those are just like closed bracket with some indentation and semicolon. The bit of flow is really like, invoke function, then compose, and then there's a lambda. So when the scraper thing is finished, then compose this, and then when detect plates works, then invoke draw, and then when that's finished, then invoke post to Twitter and Slack. And we've got error handling down the bottom, right? When complete, there's definitely going to be exactly one of a value or a throwable. I hope your error handling in your code is better than mine. Right? Just posting a message to Slack with an error. Hello. Where's the question mark, sorry? Yeah, that's a good point. No, you do know the type. That's a mistake. So we've defined a response. So if you look up on line 4, right, the invoke function scraper returns a thing of this type here. If it returns something that doesn't coerce into that type through like JSON parser, then there's going to be a runtime error. But as long as the things do return the type that they're supposed to, then these can only be composed in a type-safe manner. Right, so you have that at compile time when you're building this function. You couldn't send the result of, you couldn't assign this to some other value and then, yes, so you're right, yes, good point. Sorry. So you've got this error handling, and if you know the completable future API as well, it's got this method on it, then compose, and we're only using it in a very simplistic way here to compose. So when this is finished, then do that, right? But what you could do is say, if it finishes and the response was like some kind of network error, then compose, just retry it, like wait a couple of seconds and retry, back off, and that kind of thing. So you can modify the execution graph at runtime with this. And this is all unit testable, type safe, kind of futures-based programming. So there's a little bit of callbackness about it, the way it gets more and more indented. But you can abstract things better. I did this in a particular way to make it fit on one slide. When you run it, then you get an output. This is our kind of prototype UI for Flow. So you get the thing at the top. It does some scrapes, and then all these detect plates happen in parallel. And then for ones where the detect plates is successful, it does the drawing. And then down the bottom, you'll see some posting to Slack as well, and posting to Twitter. So you get this with very little code, right? You get this distributed, complex kind of app built up of small independent functions and then a kind of orchestration function over the top. That's what Flow is. So what's next? Okay. Oracle is building FN as a service. It's going to be called Oracle Functions, and that should be released later this year. So that's what most of the team's working on at the moment. I concentrate on the open source side of things, and there's a couple of other people do that as well. We're always looking for more contributors. We're trying to find more people who would be able to run it in production. So far, it's not only us that's running it in production, but we want more people and more use cases. There's a list of easy to get started with kind of bugs, like good first issue kind of issues. And collaboration and standardization. So we're working with the CNCF to try and build up, on top of the cloud events thing, which is, I showed you the cloud event earlier. That's like a cross-cloud, a cross-vendor standard for describing events. So recently, for example, the CNCF has decided to look at defining serverless workflows and building up a common definition of those. The idea is maybe one cloud vendor has really good, AI capabilities. Another one is one where you've been using a database for a long time and you have a lot of data there, and you want to be able to orchestrate things to work across clouds. And we're really interested in that. We're really not interested in having people locked into our particular thing, right? That's another reason why we've chosen to use containers as the deployment format. So now, I'd like to try out, if you don't mind, being guinea pigs, another FN example. Okay? So it's one of these ones where I would like you to use your phones, get on the conference Wi-Fi, I guess. I don't know if there's GPRS signal or whatever, 3G down here. But if you hit that QR code, please do as many of you as possible. You should see a page that looks a little bit like this kind of gray square here. Where am I here? Yeah. And I'm just going to watch what containers are running on my server. All right, so you can press buttons on this one. And the average kind of button press amongst a lot of you is what's being represented on the left-hand one. So what's happening is, first of all, I'm hacking it a bit because I was to finish this off at 3 o'clock in the morning. I'm using a function to serve up these web pages as well, right? But I didn't want to have anything complicated in that function. So let me show you what that function looks like. Can you read what's on this? Maybe if I make it a little bit bigger. So if I look in control, no, joystick function. So I've got a Docker file here, which is just starting from Alpine, adding an HTML file, and then the behavior of the function is just to run cat and just send that file to standout, right? So I'm kind of cheating and using the FaaS platform as a web server for static pages by doing that, right? When you click on something here, it's hitting this other URL, which is send control function. And this is a Java function, which I'm going to full screen it for a moment. It just opens a connection to a database. This is firewalled off, so I don't mind showing you all the secrets. And it inserts the data that you send into a table. So you press left, and it puts left and a timestamp in the thing, right? Because this is a hot function, because people are calling it frequently, it's going to remain hot, which means this constructor is run once, and then the connection is alive as long as the container is alive, right? So if people keep using it and it stays up, then there's no sort of like rapid reconnection of everything to and from the database. So that's a way you can like use hot functions to your advantage to do some kind of statefulness, but you can't really rely on it, right? If lots of people hit it at once, then there's going to be new functions created, and then there's going to be new database connections created, right? So you can't rely on there being state, but you can use it as a cache if you want. Right, so this one over here, you've probably guessed, is just showing like a rolling average of the last 1 second of button presses. So if you all keep pressing, that would be cool. And what we can do with this is play Pac-Man. So wait for this to reload. This is like maybe 5 or 6 years ago, I was really into Clojure, and no, this is longer. It's like 7 or 8 years ago. Clojure Script came out, and I got really into Clojure Script, and I wrote this game of Pac-Man based on it. So let's go. We can like try and avoid the ghosts. And all this is running through. It's a little bit laggy, I think, because of the number of hops that are involved. And this thing on the left is only polling the database once a second. So it's not. See, like go up is the best way. What I found was the ghosts in Pac-Man, their behavior is really interesting. If you see, it doesn't show when they're. When I start it up, right, there's these colored dots, and that's each ghost has a different targeting algorithm for where to go. And you can see the red ghost is always targeting Pac-Man. The pink ghost is always trying to get a little bit in front of Pac-Man. And the blue ghost is trying to get, so if you've got like Pac-Man and the pink ghost, the blue ghost is trying to get the other side. And the brown ghost tries to go towards Pac-Man, but if he gets too close, he gets scared and runs away. So I found a blog post that detailed all this kind of stuff, and I wrote this, and it was like trivially easy to build. Well, I say trivially easy. I was up till 3 a.m. doing it, but I was able to build in a few hours this kind of distributed averaging joystick based on FN, which is just running on my laptop, by the way. Shit, you keep dying. So using like 5 or 6 functions, some just like writing to a database, reading a rolling average of the last second's worth of behavior. Sorry, red. That red ghost is like violent, doesn't like you. This was a really fun example of something that was very easy to build because I didn't really have to worry about like running a web server or like keeping anything, like fitting any particular paradigm. I wrote functions in 3 different languages to be able to get this to work. And it's just like a bit of fun that I thought I would give you to thank you for coming down to the basement and coming here just before lunch when I know you're all hungry and eager to get to the front of those queues. So what I'll do, if there's more questions, if there's any questions about FN or about Pac-Man or about Clojure or about like anything, feel free to ask me. You can find me. I'll be around at the conference for the whole of the rest of the day. Otherwise, oh, hang on. Just need to bring Pac-Man back to life. Otherwise, yeah, have a nice rest of the time at DevOps Poland, and I'll finish here. All right? Thank you.